Yes, students, good evening to all of you. Today, successfully 3 topics are over. Atomic structure completed, periodic classification completed, and chemical bonding completed. Now we start chemical equilibrium. One of the nice topic, Nana. Definitely have the again one 4 marks question. Definitely have the 4 marks question from this topic, Nana. Now see this concept. What is Le-Chatelain's principle? Discuss briefly factors affecting the equilibrium of the given reaction. Equilibrium of what? Given reaction. Now simple statement I am saying, Nana. See the concept. Yeah, good evening, MDJ. See what is the meaning of Le-Chatelain's principle. For example, stress applied over the reaction. What I am saying, students? Stress is applied. Simple logic, no confusion. See, when stress is applied over the reaction, what I am saying, repeat the logic once again. Wait for 1 second, Anna. The streaming is continued. Wait for 1 second because network signal is weak. Yes. Now see, Nana, what is Le-Chatelain principle? The principle states that stress applied over chemical reaction. Repeat the statement. Stress applied over chemical reaction in terms of what? In terms of pressure or temperature or concentration. Repeat the statement once again. Stress applied over the chemical reaction in terms of what? Pressure, temperature or concentration over the reactant side. Over the what side? Because you want the product formation over the reactant side. Equilibrium shifts in forward direction. Equilibrium shifts in forward direction towards the formation of products. Towards product formation. Simple logic I said here. Repeat the statement once again, Nana. Towards the product formation. Repeat once again. So the Le-Chatelain's principle explains that stress is applied over the chemical reaction. Now see, the stress is applied in terms of what? The stress is applied in terms of the pressure or temperature, in terms of the concentration over the reactant side. Equilibrium shift in the forward direction towards the product formation side. That is the meaning of what? Simple logic, Nana. That is called Le-Chatelain's principle. We write the statement like that. Now, what are the factors affecting that equilibrium? Now, see the factors affecting equilibrium. The first factor, effect of the pressure. See the first factor, students. Simple factors we discuss. The first one, effect of the pressure. Okay, yes, Nana. Yes, Chandrakala, of completion of this, we discuss about pH of acid and bases. Don't worry. As per the board syllabus, we said. Okay, Nana, Nikit, as per the board syllabus, we said, yes. First, we discuss about effect of the pressure. Now, regarding effect of the pressure, you take the one reaction. N2 gas plus what? 3H2 gas gives rise to equilibrium symbol of what? 2NH3 gas. So, this is the reaction have to be taken. So, to this reaction, when pressure is applied, for example, say here N2 gas is what? 1 mole, H2 gas 3 moles, and ammonia gas 2 moles. Here, 4 volumes of the reacting gases changes to what? 2 volumes of the product gases. That means in the forward direction, volume of the gases decreases. As volume of the gases decreases, high pressure is applied in forward direction. What I am saying? Higher pressure is applied in forward direction. That is the simple statement. Because in the forward direction, volume decreases, high pressure is required. And take the next example. For example, take the example of the PCl5 gas. PCl5 gas gives rise to what? PCl5 gas gives rise to PCl3 gas plus Cl2 gas. Now see, so 1 mole of PCl5 gas means this is 1 volume. This is 1 plus 1 is what, Nana? 2 volumes. That means in the forward direction, volume of the gases increases. As volume of the gases increases, now low pressure is applied for dissociation of PCl5 gas. What is applied, students? Low pressure is applied for dissociation of what? Low pressure is applied for dissociation of the gas. Simple logic, no confusion. That means generally in the given reaction you want the product formation. You want what formation? Product formation. In the synthesis of the ammonia, what happens? In the forward direction volume decreases, that's why high pressure is applied, right? So towards dissociation of PCl5, in the forward direction volume increases. As volume increases, low pressure is applied. That is the effect of the pressure. Now go to the effect of temperature. Understood? Very easy, Nana. Chemistry IPE question papers are very easy, not so much difficult, right? And go to the effect of the temperature. Now take the one example. Take the example of N2 gas. Nana, take the example of what? N2 gas plus 3H2 gas. For example, the given reaction is exothermic reaction. N2 plus 3H2 gives rise to 2NH3. Synthesis of the ammonia. Enthalpy of reaction minus 46 kilocalories. That is the enthalpy change of the given reaction. In the synthesis of the ammonia, 46 kilocalories of heat is liberated. That means in the reaction, when heat is liberated, for the equilibrium shift in the forward direction, low temperature required. Equilibrium shift in forward direction. Tell me what I am saying. Equilibrium shift in forward direction, low temperature required. What is required, students? Low temperature is required because from the reaction heat is liberated. That is called exothermic reaction. For exothermic reaction, low temperature is required. Understood? And go for the next example. And next example, for example, go for this dissociation of the limestone. Now see, CaCO3 on heating gives rise to CaO solid plus what, students? CO2 gas. This is the example of what? Endothermic reaction. In the examination, you write the equation like this. It is easy to understand. You write the equation like this. Definitely the examiner is highly impressed. Nana. Examiner is highly impressed. CaCO3 solid on heating gives rise to what, Nana? CaO solid plus CO2 gas. The delta H of reaction is what? Plus Q kilojoules. This is what? Endothermic reaction. So what is endothermic reaction? For dissociation of limestone in endothermic reaction, high temperature required. Tell me what is required, students? High temperature is required for dissociation of what? For dissociation of the limestone. So this is the effect of the temperature. Repeat the statement once again. If your reaction is exothermic reaction, shift of equilibrium in forward direction, low temperature is required. If your reaction is endothermic reaction, for dissociation of the limestone, high temperature is required. Tell me what is required? High temperature is required. Simple statement, no confusion. This is the effect of what? Temperature. Just to write the statement like that, you get the full marks with example. Nana, understood what I am saying? Understood, Narendra? What I am saying is understood, Narendra? Yes. And next one, effect of pressure completed, effect of temperature completed. Go for effect of the concentration of the gases. Next one, effect of what? Effect of concentration of gases. Tell me what I am saying. Effect of concentration of the gases. Actually, concentration of the gases are taken in terms of the moles per liter. Take the one example. 2 moles of the SO2 gas plus O2 gas. All I said, if any example is there, better to write with example. Now see, this is 2 moles of SO2 gas plus O2 gas gives rise to 2SO3 gas. Yes or no? Yes. For example, here at the equilibrium of this reaction, continuous removal of the, what I am saying, continuous removal of SO3 gas concentration. What I am saying, continuous removal of the SO3 gas concentration, equilibrium shift in what? Equilibrium shifts in forward direction. Simple statement, students. Because from the equilibrium, the concentration of the SO3 gas is continuously removed. Now equilibrium shift in what? Forward direction. Or you can do one thing. What? You can do one more thing. Continuous addition of concentration of what? Continuous addition of concentration of the SO2 gas or O2 gas. What I am saying? Continuous addition of concentration of what gas? SO2 gas or SO2 gas. Now also equilibrium shift in forward direction. Equilibrium shift in what direction, students? Equilibrium shift in forward direction is the simple statement. That means with respect to concentration of the gases, continuous addition of the concentration of the reacting gases, equilibrium moves in forward, or else continuous removal of the concentration of the product gas, equilibrium moves in forward. Simple logical question, no confusion about this logical point. Understood? This is the effect of concentration of the gases. And next one, addition of the noble gases to the equilibrium of the reaction. Next, what I am saying? Next I am saying addition of the noble gases. Addition of noble gases over equilibrium of reaction. Addition of noble gas over equilibrium of the given reaction. Now see addition of the noble gases. Take the one example. For example, say you take one simple example of the PCl5 gas gives rise to what? PCl5 gas gives rise to PCl3 gas plus Cl2 gas. What I am saying, students? Addition of noble gases over equilibrium of the reaction. PCl5 gas gives rise to PCl3 gas plus Cl2 gas. Right, students? Now, when noble gas is added at constant, what I am saying? When noble gas is added, say the noble gas argon. Tell me, students. The noble gas, one of the noble gas is what, Nana? Argon is added at constant volume. Argon is added at constant volume. Equilibrium have no effect. Noble gas argon is added at constant value because volumes are constant. Equilibrium have no effect. Simple statement. See, the same noble gas argon is added at constant pressure. The same noble gas argon is added at constant pressure. When noble gas is added, equilibrium moves in the direction. Simple statement, Nana. Equilibrium. EQ means what? Equilibrium moves in the direction. Equilibrium moves in the direction where number of moles of gases increases. Where number of moles of the gases. Where number of the moles of the gases increases. One of the simple statement. Repeat the statement once again, students. When noble gas is added, argon at what? At constant pressure, equilibrium moves in the direction where number of moles of the gases increases. For dissociation of PCl5, this is what, students? Simple logic, students, no confusion. PCl5 is what? 1 mole. PCl3 is what? 1 mole. And Cl2 is what? 1 mole. So 1 mole becomes what? 2 moles. So to the above reaction, equilibrium shift in the forward direction. Equilibrium shift in what direction? Equilibrium shift in the forward direction, because in forward direction number of moles increases. Number of moles, what happens, students? Increases. Understood what I am saying? Simple logic, Nana. So when noble gas is added at constant volume, equilibrium have no effect. When noble gas is added at constant pressure, equilibrium moves in the direction where number of moles of the gases increases. So to this reaction, 1 mole of the PCl5 gas gives rise to 2 moles of the PCl3, Cl2 gas. That's why equilibrium moves in the forward direction. Simple. These are the factors affecting the equilibrium. The first factor is pressure factor. Second factor is temperature factor. Third factor is concentration factor. And fourth factor is what? Addition of noble gases. Each factor carries the 2 marks. Each factor carries what, Nana? 2 marks each, right? And next one. So discuss the applications of the Lee-Chandler principle to the industrial synthesis of the ammonia and sulfur dioxide. Go to the first one, industrial synthesis of the ammonia. N2 plus what? N2 plus 3H2 gives rise to what? Gives rise to 2NH3. First we go for the, so synthesis of the ammonia asking. Synthesis of ammonia means what? Ask about the forward reaction. Ask about what, students? Forward reaction. Very good. Now, first we discuss about pressure factor, pressure effect. First, we discuss about pressure effect. Now, this is what 1 mole, this is 3 mole. This is what 4 volumes of the reacting gases. 4 volume of the reacting gases gives rise to what? Gives rise to 2 volumes of the product gases. That means 4 volumes of the reactants gives rise to 2 volumes. Volume decreases. Therefore, high pressure required. Pressure factor is over. And come to the temperature factor, temperature effect. Temperature effect also very easy, students. Now, actually, synthesis of the ammonia is an exothermic process. When we go to the equation, is example of exo. Delta H of reaction minus means what? Delta H of the reaction minus means that is called exothermic reaction. In the reaction, heat is liberated. In the reaction, when heat is liberated, low temperature sufficient for synthesis of the ammonia. Low temperature sufficient. So low temperature sufficient to synthesis of what? To ammonia synthesis. But at very low temperature, so the yield is less. That's why the moderate temperature is applied. The moderate temperature is applied because at very low temperature synthesis is less. To maintain the yield of synthesis of the ammonia is more. Moderate temperature should be required. One of the important nice point. Understood what I am saying? That is called what, Nana? Temperature effect. And come to the concentration effect. Come to what, students? Concentration effect. Now regarding the concentration effect, what am I saying? Regarding the concentration effect is taken simple logic. So already this is said, I said. So this is the synthesis of the ammonia equation. N2 gas plus 3H2 gas gives rise to 2NH3 gas. Now continuous addition of what? Continuous addition of concentration of the reactants. Concentration of what? Continuous addition of the concentration of the reactant gases or continuous removal of the ammonia. What I am saying, as I said this student, Nana, continuous addition of concentration of reactant gases, continuous removal of what? Continuous removal of the ammonia gas concentration from equilibrium. From what? Equilibrium. Now equilibrium shift in forward direction. Equilibrium shift in what direction, students? Equilibrium shift in forward direction. Simple statement. That is the concentration effect. And go to the addition of noble gases. See? Next one, last one. Addition of the noble gas. Addition of the argon gas. Simple explanation. So when argon gas added to the synthesis of the ammonia at constant volume, when argon gas is added at constant value, equilibrium have no effect. That means argon gas is added. Tell me what I am saying. Addition of argon gas at constant volume. What I am saying, at constant value, when argon gas is added, equilibrium have no effect. What I am saying, students, equilibrium have no effect. But the same argon gas added at constant pressure. What I am saying, when same argon is added at constant pressure, equilibrium moves in number of moles of the gases increases. Equilibrium moves in what, students? Number of moles of the gases increases. That means IE. IE means what? That means moves in the backward direction. This is the synthesis of the ammonia. Applications of the Lee-Chadley's principle. Applications of what, students? Applications of the Lee-Chadley principles like this. Any doubt? Simple explanation, Anna. No confusion regarding this explanation. Easy explanation. No confusion regarding this explanation. Right? Yes. Yes, Nana? Now next one is what? Applications of the Lee-Chadley principle towards the synthesis of the SO3 gas. Synthesis of what? SO3 gas. Right? Now take the example of 2SO2 gas plus O2 gas gives rise to what? Gives rise to 2SO3 gas. Understood what I am saying? 2SO2 gas plus O2 gas gives rise to what, students? So 2SO3 gas. The same application we write. First of all, effect of the pressure. This is 2 volumes. This is 1 volume. This is 2 volumes. 2 plus 1. 2 plus 1 means what? 3 volumes. 3 volumes becomes what? 3 volumes becomes 2 volumes. That means volume decreases. As volume decreases, so the high pressure is required, because in forward direction, as the volume decreases, high pressure should be required. Pressure is over. And come to the example of the temperature. Actually, this is example of what? Example of the exothermic reaction. What is exothermic reaction? Amount of heat liberated, minus Q kilojoules. Because of the exothermic reaction, so low temperature sufficient for synthesis of the S4 gas. Low temperature is required. But to increase the yield of the S4 gas, we can use the moderate temperature. Easy concept. Come to the concept of the concentration of gases. So that is very easy. Continuous addition. Addition of what? Addition of continuous. Tell me what I am saying. Continuous addition of SO2 gas or O2 gas. Continuous addition of SO2 gas or O2 gas. Equilibrium shift in forward direction. Shift in what is, students? Shift in forward direction, or continuous removal of SO3 gas. What I am saying? Continuous removal of what? Continuous removal of the SO3 gas also. Now the equilibrium shift in what? Shift in forward direction. This is one of the simple logic. Or we can use noble gas is added. What I am saying, students? When noble gas is added at constant, say noble gas is argon gas is added at constant pressure, no F, at constant volume. Already this point is said, Honest student, this point already said. So argon gas is added at constant value. Equilibrium have no effect. Equilibrium has what, no effect. But when argon gas is added at constant what? Argon gas is added at constant pressure, equilibrium shift in backward. Why equilibrium shift in backward direction, Anna? Because in the backward direction, number of moles of gases increases. Number of moles of gases, what happens? Increases. Yes, Nana? Yes, brother. Jayan, don't worry, Nana. Completion of this, I said this. In this topic, you get the 2 marks questions of SDK and basic purpose. Don't worry, Jayan. I said that questions also Jayan. Don't worry, Jayan. Right, Nana? Okay. Now explain the concept of S. We have come to this concept of the acid bases. Right, Jayan? Explain the concept of Bronsted acids and Bronsted bases. The illustrate answer with showable examples. Yes, Jayan? Now see. First of all, what is Bronsted acid? Simple logic. Bronsted acid means what? H plus donor. Right? So what are the examples of the H plus donor of the Bronsted acid? Hydrochloric acid, sulfuric acid, nitric acid, all are the examples of the Bronsted acids. And acetic acid, right? And formic acid, what are the example? Formic, some of the examples. Come to the example of the Bronsted base. What is the Bronsted base? Bronsted base means what? H plus ion acceptor. Tell me, students, H plus ion acceptor. So what is the example of the Bronsted base? H2O, because of lone pair accept H plus. Ammonia, because lone pair of the nitrogen accept H plus, and OH minus accept H plus, NH2 minus accept H plus. So, and we write one more important point. So what is the meaning of that? Say for example, conjugated acid base pair. That means conjugated acid base pair means a base pair which differs by a single H plus. Tell me, a pair which differs differed by single proton. What I am saying? The pair which differs by single proton, that is called conjugated acid base pair. Take the example, hydrochloric acid. So hydrochloric acid means what? It loses H plus ion, forms what? Cl minus ion. So hydrochloric acid is a what? Acid, and Cl minus ion forms what? Conjugated base. Now this is called what? Conjugated acid base pair. Simple logic. That means a acid base pair which differs by a single H plus. Tell me what I am saying. The acid base pair which differs by a single H plus ion. Understood, students? Very good. Now one more example you take it. Take the example of the OH minus. So I should do this Cl minus again adding of H plus. So it's Cl forming. It's a reversible reaction to the OH minus by loss of the H plus, and what you got? You got O minus 2 ion. What you got, students? O minus 2 ion. Now here OH minus is a acid. The corresponding O minus 2 ion is called what? Conjugated base. Is called what, student? Conjugated base. Now to this conjugated base, tell me what I am saying. To this conjugate base, when H plus is added and forms OH minus. That is the meaning of what? Conjugated acid base pair. So these are some of the examples. You can write a 4 marks question like this. Right, Nana? And see next one. So explain Lewis acid base theory with short example. Classify the following species into Lewis acids and Lewis bases. Simple logic, student JN. What is Lewis acid, JN? Electron pair acceptor. Electron pair acceptor is called Lewis acid. What is Lewis base? Lewis base means what? Electron pair donor. Tell me. Electron pair donor. Electron pair acceptor is called acid. Electron pair donor is called what? Lewis base. Now, classify the following species into Lewis acids and bases. Show them acts as Lewis acid. Actually, H plus ion acts as a Lewis acid. Why H plus ion acts as Lewis acid? Because in the H plus ion, 1s0 is there. Because of the 1s0 is completely vacant, is electron pair acceptor. Now see, this F minus, the F minus acts as what? F minus acts as Lewis base. Because of negative charge acts like a donor. And here OH minus negative charge is there, so this acts like a Lewis base. The negative charge means what? Negative charge means 2 electrons Jn. Negative charge means what, Jn? 2 electrons. Understood, Narendra? Nikit, understood? Akshay Kota, understood? Karthik, MD Jain. Yes, Nana. Negative charge is 2 electrons, that's why this is a Lewis base. Simple statement like that. And go to the next example. Derive the relation between Kc, Kp for equilibrium reaction. Simple formula. What is the formula? Derivation Kb is equal to Kc RT whole power delta N in the gas state. Yes or no? Now delta N in gas state, what you write, Nana? Nb in the gas state minus Nr in the gas state. Now tell me, for this reaction, synthesis of this ammonia, so Nb 2 moles and reactant, this is 1 mole, this is 3 moles. Now what you write? 2 minus 4. 2 minus 4 is equal to minus 2. Delta in gas state how much? Delta in gas state is minus 2. Understood what I am saying? Therefore, Kp is equal to Kc RT whole power minus 2. From that what you get? Kp is equal to Kc by RT square. Therefore, what you write? Kp into RT square is equal to Kc. Tell me what I am saying? Kp into RT square is equal to Kc. This is an important 2 marks question. So this is for 2 marks and this is for what? 2 marks. 2 plus 2 is 4 marks question. Right, Nana? And take this example. 2SO3 plus what? O2 gas gives rise to 2SO. Again the same explanation, students. What you write? Kp is equal to Kc RT whole power delta N in the gas state. So what is the reaction given? The reaction given like this. So 2SO2 gas plus O2 gas gives rise to 2SO3 gas. Now tell me, delta N in the gas state is equal to Np in the gas state minus Nr in the gas state. Now what you write? 2 minus 3 is equal to minus 1. Therefore, Kp is equal to Kc RT whole power minus 1. From that, Kp is equal to Kc by RT. So from that what you write? Kp into RT is equal to Kc. Therefore, Kc greater than Kp by how many times? How many times means that is RT times. Kc greater than Kp how many times, students? RT times. Simple logic, no confusion. And see the next one, Nana. So all this is question explained. Applications of the Leach principle, industrial synthesis of the ammonia by AMS process, this is already explained. And see the next question. So Already this is given. What is conjugate acid base pair? Illustrate with example. Yes, Nana. Hydrochloric acid is a acid. Acid means what? Lose of the H plus and forms Cl minus. So hydrochloric acid is a acid and forms what? Corresponding conjugated base. Now to this base again H plus ion is added, forms HCl. That is the meaning of what? Conjugated acid base pair. The base pair which differs by a single H plus nano. The base pair which differs by what, students? Single H plus. That is the example of the conjugate acid base pair are they given. Understood what I am saying? Now write conjugated acid base pairs for the following species. Yes, Nana. So to the H2O. To the H2O. What is conjugated acid? Conjugated acid means, you remember the definition of base. You remember what, students? Definition of the base. Conjugate acid equal to what? Definition of the base. Base means what? Loss of H plus ion forms what? OH minus. So conjugate base equal to definition of the acid. See, Nana? Conjugated acid is equal to, we remember definition of the base, Nana. Array, Nana, simple logic. Conjugated base equal to, you remember the definition of the acid. Right? What is the definition of acid? So to the H2O, what is acid? Acid means what? H plus ion acceptor and forms what? H3O plus ion over and come to the ammonia. Come to what, students? Come to the ammonia. So with respect to ammonia is taken. So what is conjugate acid? Definition of the base. Base means what? Loss of H plus ion and you get what? NH2 minus. Understood what I am saying? Yes. So ask about to the ammonia. Conjugate base means what? Definition of acid. Acid means what? H plus ion acceptor and Nana, do rest now ma. So H plus ion acceptor and you get what? Ammonium ion is forming like that. Understood? Yes. And come to the HCO3 minus. Come to simple logics, Nana. Chemistry is very easy. Simple logics. For HCO3 minus ion, what I am writing? For HCO3 minus ion by loss of H plus. So loss of H plus means what? H plus losing means what? Definition of acid. Yes or no? And you get what? CO3 minus 2. When H plus ion is accepted, know what you get? And you get H2CO3 like that. Loss of H plus ion is called acid. That is the conjugate base. The conjugate base of HCO3 minus is CO3 minus 2. Acceptance of H plus ion is called base. So what is the conjugate acid of HCO3 minus is what? H2CO3 like that. Understood? Yes, yes. And see the next example. HSO4 minus. What I am saying, students? HSO4 minus ion. Regarding HSO4 minus ion, what is the meaning of conjugate base? Conjugate base means what? Definition of acid. Loss of H plus ion, what you get? You get S minus 2 ion. And to the HSO4 minus, adding of H plus ion is called conjugate acid. What is conjugate acid? Definition of base. Base means what? H plus ion acceptor and you get H2SO4. Understood? Very easy, Nana. Lose of H plus ion is called acid. Acid means what? Nothing but conjugate base. Acceptance of H plus ion is called base and forms what? Conjugated acid like that. Simple logic, Nana. That's why you remember the simple logic. Conjugated acid asking. Conjugate acid asking, you refer the definition of the base. Conjugated base asking, you refer the definition of acid. Refer the what? Definition of the acid. Understood what I am saying? Yes, like that. And see next one. Define pH value. What is buffer solution? And ask about derive the hand. See, Nana, this derivation is not there. In the 30% syllabus, derivation is not there. But I give a statement. In the 30% syllabus, the derivation of Handel's equation not there, Nana. Understand, students? Yes. What is pH? pH of the solution is defined as simple statement. pH of the solution is nothing but minus negative logarithm to the base 10 of what? He plus ions concentration What is the meaning of pH solution? Negative logarithm to the bastion of what? H plus ions concentration is known as pH. What is buffer solution? Simple logic. Solution maintains, see, solution maintains constant pH value. Solutions maintains constant pH value by adding few drops of strong acid, by adding few drops of the strong acid or few drops of the strong base. Repeat the statement once again, Nana. What is the meaning of the buffer solution? Buffer solution means what, students? Buffer solution means the solution maintains the what? Constant pH value by adding few drops of the strong acid or few drops of the strong base or by dilution. Dilution means what, students? Addition of the water. So Henderson equation is not there, just to refer, only they given for the 2 marks question, buffer solution statement and pH value. Now see next one, Nana. How does the value of the equilibrium constant predict the extent of the reaction? This is one of the nice question, Nana. What is buffer solution, Jane? Simple as Jane. Few drops of the acid is added, few drops of the base is added to the solution, which maintains what? Which maintains constant pH value. Which maintains what, students? Constant pH value. Understood what I am saying? Yes. No confusion? Right, Nana. Very good. Very good. Now see the next very important point. For example, how does the value of equilibrium constant predict the extent of the reaction? Simple logic, brother. Generally, for the given reaction, see, for the reaction, Kc value is more. What I am saying? For the given reaction, Kc value is more. So, the concentration of the reactants are very less. Concentration of the reactants very less compared to what? Concentration of the products. The reaction ready to completion. What I am saying? Reaction is what? Ready to completion. Kc value is more. See, the Kc value is less. What I am saying? Kc value is less. Kc value less means what? The concentration of the reactants very high. Concentration of reactants very high compared to concentration of the products. So the reaction not ready to completion. Reaction not ready to completion. Reaction not ready to completion means what? Equilibrium moves in forward direction. Reaction not ready to completion, that is enough. And Kc value is moderate. What I am saying, students? Kc value is moderate. Now, so the concentration of the reactants as well as, what I am saying, concentration of the reactants as well as concentration of products will appear at equilibrium. What I am saying, will appear at what? Will appear at equilibrium. One of the beautiful, nice point. Repeat the point once again, students. What I am saying, Kc value is moderate. The concentration of the reactants as well as the products will appear at equilibrium, students. Understood, Jain? Understood, MD Jain? Akshay Code understood? Simple logic, Nana. Kc value is more. Concentration of reactants are very high compared to concentration of reactants. Reaction ready to completion. You write the question or statement like that. And this point is what? Kc value is less. Concentration of reactants are very high compared to concentration of products. Reaction not ready to completion. Kc value is moderate. Concentration of reactants as well as concentration of products will appear at equilibrium. And one more important point is there. See, for example, if your reaction is exothermic reaction, in exothermic reaction, as temperature increases, what I am saying, in exothermic reactions, as temperature increases, so the Kc value, what happens? The Kc value decreases. Simple statement. Yes, that is in what manner? In exothermic reaction. Come to in endothermic reactions. What I am saying? What is endo? So amount of heat is absorbed. In endothermic reaction, As temperature increases, tell me what I have said. As temperature increases, Kc value increases. That is what in case of the endothermic reactions. Just we can predict the nature of the reaction by using this Kc value. This is one of the important bit also for the objective point of view. In exothermic reaction, as temperature increases, Kc value decreases. In endothermic reaction, as temperature increases, Kc value increases. One of the beautiful point for what? For the objective question also, right, Nana? And see the next bit, Nana. Now simple logic is there. Explain the term of the hydrolysis of the salt with examples. Discuss the pH of the following salts type of the salt solution. First of all, what is the meaning of hydrolysis of the salt? Hydra means water. Lysis means what? Breakdown of the water by the salt. How can you define the hydrolysis of the salt? So hydrolysis of defined as, now see, it's defined as, tell me what I am saying. It defined as cation or tell me, cation or anion of the salt. Repeat the statement once again, students. Hydrolysis salt is defined as cation or anion of the salt. Hydrolyze the water. Tell me, hydrolyze the water produces either H plus ions, or OH minus ions in the aqueous solution. What I am saying, either H plus ions or OH minus ions in the aqueous solution. That is the meaning of hydrolysis of the salt. Simple statement, Nana. Yes, simple logic. For example, you know cation of the salt. Take the example of the cation of the salt. AB of the salt react with water. In the water, what is there? H plus is there, OH minus is there. A plus combines with OH minus and what gives H plus ion. Like that, B minus of the salt. What is salt? A plus and B minus. Salt is a cation and anion. B minus of the salt combines, react with the water. So B minus combines with what? H plus ions. So water forms what? BH plus OH minus ions. That's why. So the cation of the salt or anion of the salt hydrolyzes the water, produces either H plus ions or OH minus ions in the aqueous solution. Understood, Nana? Simple logic, no confusion. That is the hydrolysis of the salt. Now discuss the pH of what? Discuss the pH of the following type of the salt solution. The first example is what? Salt of the weak acid and strong base. Next example, salt of the strong acid and weak base. Now see that. Salt of the weak acid and strong base, students. Now see the salt of the weak acid and strong base. Take the example of weak acid. Hydrocyanic acid is a weak acid and strong base. NaOH is a strong base. Now what happens? So this is what? H plus, Cl minus, Na plus, OH minus. By loss of the water, what is the salt you got? You got the salt of NaCN salt forming. Now in the salt of NaCN, HCN is a what? HCN is a weak acid. As HCN is weak acid, according to Bronsted-Lowry concept, if the acid is weak, the corresponding anion is stronger nature. Acid is weak, the corresponding anion is what nature? Stronger nature. Actually, NaOH is a what? Strong base. Because of the strong base, Na plus ion is what? Weak. Simple logic. Therefore, in the salt of Na plus and Cn minus, the Cn minus ion is what nature, students? Stronger nature. Na plus ion is what, student? Weaker nature. Therefore, the strong anion of the salt hydrolyze the water. What I am saying, student? The anion of the salt is the stronger nature. Because the anion of the salt is the stronger nature, the anion of the salt hydrolyzes the water, produces HCN aqueous plus OH minus ions. Now in the solution you get OH minus ions. OH minus ions means what, students? Basic nature, and the pH is what? pH is more than 7. So the red litmus paper in the salt solution. Red litmus paper in the salt solution turns to blue color. Tell me, red litmus paper in the salt solution turns to what color? Blue color. This is completed. And take the next example. Salt of the strong gas and weak base. It's very easy, students, no confusion. Red litmus turn to what color? Blue color. Yes, Mokesh, 45. Is clear, Tamilu? Yes, Nana. Very easy. And take the example of the strong acid and weak base. Example of the weak strong acid. Hydrochloric acid is a strong acid. Weak base. Best example, ammonium hydroxide is a weak base. Now from that, both are combined gives rise to what? Ammonium chloride salt forming. Tell me what salt forming? Ammonium chloride. Now by loss of the what? By loss of the water. Any doubt? You have it. So hydrochloric acid is a what? Hydrochloric acid is a strong acid. Ammonium hydroxide is a weak base. So this is what, Nana? This is a strong acid. If acid is strong, the corresponding Cl minus ion is weak, and ammonium hydroxide is a what? Weak base. Weak base means what? Corresponding cation is strong. Simple logic. Now you tell me, in the salt of this ammonium chloride, in the salt of this ammonium chloride. So the ammonium cation is what? The ammonium cation is stronger nature. Whereas Cl minus ion is what? Cl minus ion is weaker nature. Why the Cl minus ion is weaker nature? Because coming from the strong acid HCl. Why NH4 plus ion is stronger nature coming from the weak base ammonium hydroxide. Therefore, the salt of the ammonium cation of the salt, strong or weak, strong nature, hydrolyze the water. When hydrolyze the water, it gives what, students? It gives NH4OH aqueous solution plus H plus ions. H plus ions means what nature? Acidic nature. Acidic nature means what? Acidic nature means here the blue litmus paper turns to red color. pH is less than 7. So blue litmus paper, tell me students. So blue litmus paper turns to which color? The blue litmus paper turns to reddish color. Simple logic is there, and pH of salt solution is less than 7. Less than what, students? 7. Yes, Nana. Nanda Kumar. Catalyst increase the rate of reaction, Tamadu. Catalyst decrease the activation energy of the reactants. Nanda Kumar. Nandhu. Catalyst decrease the activation energy of the reactants. By the rate of the reaction, what happens? Nandu increases, right? So this is the example of what? So this is the important questions. Now see the next very important, Nana. So if you have any doubts, please tell me. So clear what I am saying? Now simple problems are given. How the problems are given? So simple IPE problems are given. We check out for the IPE problems. How the IPE problems are given, Nana? See, calculate pH of 0.05 capital M H2SO4 solution. Maybe this question is given as IPE 2 marks questions, Nana. But these questions are very, very important for IPE 2 marks. Yes, Nana. As per the syllabus, as per the blueprint we are going, Nana. So the organic chemistry comes after 3 days. Mokesh. The organic chemistry comes after what, Nana? 3 days. Right, Mokesh? As per the blueprint we are going. Right. Calculate pH of 0.05 molar H2SO4 solution. Actually, pH problems are done in terms of the normalities. In terms of what, students? Normalities. Now, basing on that, normality with respect to what? Normality with respect to H plus ions concentration is equal to molarity into number of H plus ions. Molarity into what? Number of H plus ions. Here molarity given how much? The molarity given 5 into 10 power minus 2 into 2H plus ions. That becomes what? 10 power minus 1. That is the normality with respect to H plus ions. Now from that, what you write? pH is equal to minus log to the base 10 H plus ions concentration. That is equal minus log to the base 10 power minus 1. So the minus 1 comes front side into minus log to the base 10. Log 10 value is what? 1. Minus 1 into minus 1 is equal to plus 1. Simple logic, understood? Repeat once again, students. pH problems are done in terms of what? pH problems are done in terms of the normalities. So normality with respect to H+ ions is equal to molarity into number of H+ ions. Yes or no? Yes, Nandakumar. Very good, Nana. Yes, MD Jain. Tomorrow it comes, Nana. State summary comes in tomorrow class. MD Jain, right? MD Jain. So Nandakumar. Yes, very good, Nana. Thank you, Nana. So, but this is the one of the best objective academy, Nana. One of the best objective academy for advance and mains for the beneficial of the students. So the Ramarao sir is the very kindly hearted person. He gives the free online YouTube classes, Nana, to make the best score in your IPE classes. That's why the free classes have no amount, right? Yes, only my some students are there. MD Jain is my student. Okay, right? Yes. Now see. So this is the problem. For example, the question given like this now. Calculate. See, Nana. Calculate pH of what? Calculate pH of 0.05 molar calcium hydroxide aqueous solution. Simple questions are given. Difficult questions are not given, Nana. Calculate pH of what? Calculate pH of the 0.005 molar calcium hydroxide solution. Actually, calcium is a metal. Metal forms what? Base. First, you have to find out normality of the calcium hydroxide. Normality of the calcium is a metal forms base. Normality of calcium hydroxide molarity is what? 5 into 10 power minus 2 into 2. That becomes what? 10 power minus 1. First, for the base, first you have to find out pOH. pOH is equal to minus log to the base 10 power minus 1. That is equal minus 1 into log to the base 10. Now minus 1 into minus 1. That becomes what, Nana? That becomes plus 1. That is the pH value. Because our discussion at room temperature, our discussion at room temperature, that's why pH plus pOH is equal to 14. Therefore, pH of the calcium hydroxide is equal to 14 minus 1, that is equal to 13. Understood this concept? Very easy. Yes. And go to the next question. For example, one question is given like this. Calculate pH of 0.005 normal is given. Sometimes given to make the confusion. It's a 2 marks question, because of 2 marks question, a simple logics are given. What are given, students? A simple logics are given. Understood what I am saying? Right, Nana? Yes. Calculate pH of 0.005 normal. pH of 0.005 normal. Strontium hydroxide aqueous solution. Strontium hydroxide aqueous solution. Right, students? Yes. Now go to this concept. Now regarding this concept, we write like this. So first here normality is given, molarity is given, normality is given. Tell me what is given, students? Normality is given. Understood? Very good. Now based on that, so if normality is given, no need to convert into molarity. If normality is given, no need to convert into what? Molarity, right? Therefore, normality of what? Normality of the strontium hydroxide is equal to, so what you write? 5 into 10 power minus 3. So from that, because base for base you have to find a pOH. pOH is equal minus log to the base 10. So 5 into 10 power minus 3, students. Now from that what you get? From that you get minus log to the base 10 5, right? Minus log to the base 10 power minus 3. Now log 5 is what? 0.68. Now this is minus 3 into minus log to the base 10. Now from that minus 0.68 plus 3, that is equal to 2.3. But the pOH value? The pOH value is 2.3. And you want pH. And you want what? pH. You are very well known. pH plus pOH is equal to 14. Therefore, pH is equal, what you get? 14 minus 2.32. So from that, what you get? 14 minus 2.32. So you get 11.68. pH is more than 7, that is basic nature. So pH is what, Nana? You are very well known. pH is more than 7, that is what nature? Basic nature. Simple logic like this. Now Jayant understood. So these kind of the problems you are asking. I think so. Right, Nana? And see the next question. And the simple 2 marks questions are given like this. Right? So for example, a question is given like this. 4 milligrams. What I am saying? 4 milligrams of the NaOH dissolved. 4 milligrams of the NaOH dissolved in water. The resulting solution. What am I saying, students? The resulting solution made to 500 ml. Calculate pH of aqueous NaOH solution. Calculate pH of what? Aqueous NaOH solution. Simple logic, students. Now see, 4 milligrams of what? 4 milligrams of the NaOH dissolved in water. Resulting solution made up to what? Resulting solution made up to 500 ml. 4 milligrams of NaOH is dissolved in water. Resulting solution made up to 500 ml calculate pH of the NaOH solution. Simple logic. All I said, pH problems are done in terms of what? pH problems are done in terms of normalities. Very good. First you have to find out normality of what? Aqueous NaOH solution. What is the formula? Weight of the NaOH by gram equivalent weight of the NaOH into 1000 by volume of the solution in ml. Understood? Very good. Now what is the weight of the NaOH? So weight of NaOH is what? 4 into 10 power minus 3 grams. Right? But what is the equivalent weight? Equivalent weight of the NaOH is what? 40 grams. Because how you get equivalent weight? So gram equivalent weight of NaOH. Simple logic. Gram equivalent weight of NaOH is equal to gram molecular weight of the NaOH by OH minus ions is 1. What is the gram molecular weight, Nana? 40 grams by 1. That is equal to 40 grams. Understood? So gram equivalent weight of NaOH is equal to gram molecular weight of NaOH is 40 grams by 1, that is 40 into 1000 by volume of solution is what? That is 500 ml. Exactly cancel. This is 2 times. The 4 is cancelled. And what you get? 2 into 10 power minus 4. What you get, students? 2 into 10 power minus 4. Understood what I am saying? Yes, Nana. Nice, Anu. Thank you, Anu. Nice. Now, from that we have to find out pOH. What you find out, Nana? pOH. So pOH is equal minus log to the base 10. So 2 into 10 power minus 4. So from that, minus log to the base 10 to minus log to the base 10 power minus 4. So what is minus log to the base 10 to? 0.30. This is plus 4. That is equal to 3.7. What is the pOH, students? pOH is 3.7. Therefore, pH plus pOH equal how much? pH plus pOH equal to 14. Therefore, pH is equal 14 minus pOH. pOH is 3.7. That becomes what? 10.3. So pH 10.3 means what? That is more than 7. Tell me, students, that is what? More than 7. Simple logic like this. Repeat the question once again. This kind of simple questions given like this, Nana. Understood, Nana? So what I am saying, 4 milligrams of NaOH dissolved in the water. Resulting solution made up to 500 ml. We have to find out normality of the aqueous NaOH. Weight of NaOH is 4 into 10 power minus 3 grams. What is the equivalent weight of the NaOH? 40 grams. 1000 by volume of solution is what? 500 ml. That is 2 into 10 power minus 4 you got. Because NaOH is what, Nana? NaOH is a base. For the base you have to find out what the pOH. For the base NaOH we have to find out what, Nana? pOH. pOH equal minus log to the base 10 2 into 10 power minus 4. This is minus log AB. Minus log A minus log B. that is minus log to the base 10 to value is minus 0.3. So this is what, this value is plus 4. That becomes what? 3.7. Therefore, pH plus pH equal to 40. Therefore, pH what you got? pH equal to 10.3 you got. pH is what? 10.3 you got. pH is 10 point, that is more than 7 or less than 7? That is more than 7. This is the complete problems on what? Ion equilibrium and chemical equilibrium. And tomorrow we start thermodynamics. Understood, Jain? No, these are doubts you are asking, Jain. Understood, Nana? Jain and followed by MD Jain and Nandakumar, Mokesh. Understood, Nana? Please respond. Anu, Mokesh 45, MD Jain, Nandakumar. And in tomorrow class we discuss about what? In tomorrow class we discuss about thermodynamics, and after 3 days we enter to the organic chemistry. Easy, Nana? No confusion. Yes. Yes, thank you very much. So, good night.